Hi all. So let's see the remaining part of instruction formats. And the contents we are going to discuss about the remaining types of instruction formats along with their advantages and disadvantages. So as I already told you, depending upon the number of addresses that are present in the address part of an instruction, the instruction formats are classified into four types: zero address instructions, one address instructions, two address instructions, and three address instructions. In the previous lecture, we have already discussed about zero address instructions, which are implemented in the computers that implement stack organization. Now we'll move on with the next type of an instruction format, which is one address instructions. So, as the name implies, the one address instructions are nothing but the particular address part of the particular instruction contains a single address or a single operand. If it is address, it is nothing but a memory location or an operand which can be stored in a register. So that is specified in the address part of an instruction. And the accumulator is an implicit register that is used in this particular one address instruction. So, and once the operation is done, the result can be either be stored in the accumulator or it can be stored at another memory location or a register. So, let's see an example of one address instructions. So, if you take this particular expression a plus b into c plus d. So, this one address instruction, as I told you, one operand will be specified in the address part of the instruction, where the other operand is implicitly the accumulator. And this one address instructions implement two special type of instructions called as load and store. You can implement this using two special instructions called load and store. So if we see this example, load A. So we are loading the value of A, loading the value of a memory word which is stored at address A in the memory location into the accumulator. Next, add B. Add B performs an addition operation on the contents of the accumulator register as well as the memory word which is stored at address location B. So, and we are storing this particular result into a temporary location. So, that is represented by T, M of T. So, in a memory, in a temporary location in the memory, we are storing the result of the accumulator. Because we have to calculate C plus D in the next step, where you have to consider the accumulator again to perform the operation. So, the result which is present in the accumulator, it is stored into a temporary location. So, M of T. Next again we are loading the value of C into the accumulator and adding it with D, M of D. So AC plus M of D. So that result is again stored in the accumulator. Now accumulator contains the result of C plus D, whereas the temporary location M of T contains the value of A plus B. Now we are performing a multiplication operation on the contents of the accumulator register and the temporary memory location which contains the value of A plus B. Now the result of AC into M of T is again stored in the accumulator. So from the accumulator, it is stored into the permanent memory location X, M of X. So M of X now contains the value of this particular expression. So this is called as one address instruction. The instruction format, the address part of the instruction format contains a single address, single address or single operand, whereas accumulator is implicitly used as a other operand. So all the operations are done here between the accumulator register and the memory operand. So if M of means it represents a memory location. M of T is nothing but it is a temporary memory location which is used for storing your intermediate results. And this instruction format, it mainly uses two special instructions, load and store. So as I already told you, load is used to transfer the data to the accumulator, where store is used to move the data from the accumulator to a memory location. Next type of an instruction format is a two address instruction format. So two address instructions are nothing but the address part of a particular instruction format contains two operands to be specific. It allows two operands. You can use one or two depending upon your requirement, but it basically allows two operands to be specified in the address part of the instruction. These operands can be either your registers or it can be a memory location. And the results can overwrite one of the source operand or it can be stored in a separate location in the memory. So if you consider the same example of a plus b into c plus d, we'll see how this can be implemented using a two address instruction format. So in two address instruction format, we are using a special instruction called move. So move. First, we are taking m of a. We have to first perform a plus b. So m of a, and this particular two address instruction, they make use of registers to perform the operation. General purpose registers. So A is first copied into register R1, moved using a move instruction. Move instruction, move R1 comma A, it transfers the operand A from the memory location into the register. Next, add. You are performing add R1 comma B, which means the contents of a register R1 is added with the contents which are stored at a memory location, M of B. Now again we are moving and the result is stored again into R1 register. Now again for C we are loading the value of C into R2 register and adding it with the content with D, R2 plus D, and the result is stored in R2. Now you need to perform a multiplication operation. One result is stored in R1, the other is stored in R2. So using a multiplication instruction, we are performing mul of R1 comma R2. It performs a multiplication of two register contents and the result is stored in one of the source operand R1. Now R1 contains the result of the entire expression which has to be moved into X. So move X comma R1 moves the contents of the register R1 into a memory location X. So M of X will contain the value of R1. So the move instruction, it transfers operand to the memory from the processor registers R1 and R2 registers. So this is an example of two address instructions which make use of registers to perform an operations. Next we move on to the next type of an instruction format, which is a three address instruction format. So here the address part of a particular instruction contains three operands. And among the three operands, two operands are going to be the source operand and one is the destination operand. Okay. So this format allows more complex operations to be performed. And this type of instruction format is basically used in high level language compilers and optimizers. So if you consider an expression a plus b into c plus d, it can be computed using a three address instruction format. So here the format contains three addresses where R1, one is a destination operand and two are the source operands. So in the first step, we are performing an addition of A plus B. So we are taking R1 as the destination operand, A and B are the source operands. So you can write it as add R1 comma AB. It performs then addition on the contents of A and B and the result is copied into R1. Similarly, next step you are performing C plus D. Add R2 comma C plus D. It performs an addition of the C and D and the result is stored at destination register R2. Now, then we are performing a multiplication operation of contents of R1 and R2. So, mul X of R1 comma R2. It performs a multiplication operation on the contents of R1 register and R2 register and the result is stored at a memory location X. So this is how a three address. So if you look at here, each and every instruction in this format contain three addresses. One is the destination address and the remaining two are the source addresses, source operands or source addresses. In case of a two address instructions, the address part contains only two addresses. It can be registers or memory locations, anything. It should specify a two address format. Similarly, in case of one address, the instruction has only one address where the other one is implicitly the accumulator. Next, coming to the advantages and disadvantages of instruction formats. So coming to advantages of having these different types of instruction format, they allows efficient processing of your instructions, and moreover easier hardware design with consistent instruction structure, and it makes the code generation very simple in order to have a high performance in coding. And you can accommodate a wide range of instructions depending upon your application and depending upon your CPU organization. You can implement either a one address instruction or two address or three address depending upon your requirement. And coming to the disadvantages of instruction format, flexibility and efficiency can be, you cannot, there is a difference in balancing between the flexibility and efficiency that can be difficult when you have these many types of instruction formats available. And moreover, if you take a three address format, which is a complex format, it can slow down the decoding capability of the particular computer. And more complex format may also reduce the speed of the particular processor. And some formats may not be applicable to the new techno, which are older type of formats. They cannot be applicable scale with the new technologies available. So these are the advantages and disadvantages of instruction formats. Thank you.